So we saw the basic configuration of GitLab CI/CD pipeline and how to configure a simple pipeline with simple jobs or steps. And we saw that GitLab automatically executes the pipeline every time we commit changes to the repository. And we also configured the logic to decide commits to which branches specifically should trigger this pipeline. Now the question is, where does GitLab actually execute these tasks? Like we executed these echo commands for each job, as well as some Linux commands like concatenation or ls or printing the current directory path, etc. And we also created temporary files and so on. So where does all this actually happen? It has to be executed on some environment, on some server, right? And obviously in our case, it's a Linux server because we executed Linux commands. But where are they hosted? And that's going to be the topic of this chapter. So let's see how GitLab architecture actually works and how the jobs and pipeline get executed. First of all, we have a GitLab server, also called a GitLab instance or installation. It is the main component of this whole GitLab architecture and has all the information about your pipeline configuration. It manages the execution of the pipeline and its jobs and stores the results. So the GitLab server knows what needs to be done, but doesn't do the job itself. The jobs are executed on what's called GitLab runners. And you can have multiple runners connected to your GitLab instance to distribute this load. So GitLab server says these jobs need to be executed, and it picks one of the available GitLab runners or agents that execute those jobs. Now, who manages the GitLab architecture? With GitLab, we have two ways of using it. GitLab itself offers a managed GitLab instance, which is the gitlab.com, that you can use to build your projects, just like you can host Git projects on gitlab.com. So that's the software as a service platform that GitLab offers. And it's managed for you by GitLab engineers. You don't have to set it up or do any kind of configuration. So this software as a service platform is the GitLab instance. Now, what about the runners that execute the jobs in our pipeline? Who created or who is managing these runners? So GitLab, with this managed solution, offers you runners that they managed for you. So what is a runner, first of all? GitLab Runner is a small program that you install on a separate machine. So not the machine where GitLab server is running, but on a separate physical or virtual machine, and it's connected to the GitLab server. And once that connection is established, GitLab Runner can execute the jobs that GitLab server sends it. And GitLab offers a list of runners that they manage and make available for all GitLab users and their projects. And these are what's called the shared runners. It's a runner that can be used or shared for all the projects in the GitLab instance on gitlab.com. So you and I, if we have accounts on GitLab and we have our projects, we can both use the shared runners that GitLab makes available and manages for us. Now, as I mentioned, GitLab Runner is a small program that we install on a server to make it possible to run GitLab pipeline jobs there. But the GitLab Runner program isn't the one that will actually execute the jobs. Let's say we have following jobs in our pipeline: run JavaScript unit tests, build a Docker image from the project, push the image to Docker repository, and deploy the new image to a development server. How would you normally execute this? Well, we have commands for these tasks, right? For example, to run the JavaScript tests, we would execute npm run tests command. We have docker build command to build the image, docker push to push the image to the repository. We can deploy to a remote server using SSH command, and so on. So these are all commands that can be executed on an operating system directly, right? Like Linux or Windows, etc. So the commands in jobs will be executed on some operating system, on the shell of the server where we installed the GitLab runner. And this is actually how jobs are executed on Jenkins. So the GitLab Runner program is actually a mediator. It will fetch the job from the GitLab server and hand over the commands of the job to the shell of the server that it's running on. And this is actually the simplest and common way of executing jobs on a GitLab Runner server. And the environment where the jobs are executed is also called a shell executor, because as I mentioned, it will be executed in the shell program of the operating system where GitLab Runner is installed. Now let's say we want to execute all the above mentioned commands on one single runner, which again is one server with GitLab Runner installed on it that hands over the commands to the shell executor. So we have an npm command, docker command, and SSH. Or if we were building a Java application, we would need Java, Maven, or Gradle, and so on in order to build and package the application. This means we would have to install these tools on the server where the GitLab Runner is installed in order to make these commands available there. Because logically enough, if we want to run docker build command, we have to have Docker tool or Docker CLI installed on the operating system. And same for Java, NPM, and other tools. So we need to install and configure these tools and update their versions and basically manage these tools on that GitLab Runner server, which means a lot of manual work for the administrators of that GitLab Runner server. Plus, when we migrate the runner, meaning we have a new server and we want to execute all our jobs there, so we basically install GitLab Runner on another server and want to move all the execution over there, we would need to install all these tools on the new runner. Now, in addition to that, let's say that this one runner is shared among multiple Git projects. Let's say you have multiple microservices and all the jobs of these microservices are executed on this one runner. And one project's job needs npm version 6, while another project's job needs an npm version 7, which means another complexity for the administrators, because now you have to manage these dependency versions when you need different versions of the same tool for different jobs. And finally, when you execute multiple jobs on the same runner, you actually have leftovers on the server from the previous job execution. So the environment gets cluttered and you have a lot of maybe temporary files or things that remain from each job execution. So executing jobs on runner's operating system directly has all these limitations. Now the question is, do we have some alternatives or better options? Yes, in fact, GitLab supports multiple execution environments or executors in addition to the shell executor. So the shell executor, as I said, is the most basic and simple one, but it has all these limitations. And a better alternative to that is Docker executor. So this is basically executing the jobs not directly on the shell of the operating system, but inside a Docker container. So on the server of the runner, a fresh new Docker container is created to run the job. So for each job, a completely new, fresh Docker container is created. Once the job is done, the container gets removed, and that's it. And this solves a couple of things. First of all, you can use images with already installed npm, Java, or whatever tool you need. So you don't have to manually configure anything on the server, except for the Docker itself. Plus, now you can choose a different version for each job as you need. So basically, you execute one job in a Docker container which has npm version 6, and you execute another job in another Docker container with npm version 7. You have no conflict of versions at all. And finally, each job will be executed in a fresh new container, as I said, so no leftovers of the previous job, and you have a clean state for each job. Now let's say your company has no know-how of Docker, so you don't use Docker at all, but instead you use virtual machines. In this case, you can actually choose to use virtual machine executor on the runner to still have the isolated environment for running the jobs. However, note that this will take longer because for every job, a new virtual machine needs to be loaded and created, which means loading the whole operating system. So obviously the whole pipeline execution will take longer. So while you still have the advantages of having isolated environment for each job and easy to manage dependency versions, etc., it slows down your pipeline execution. You also have a Kubernetes executor type, which means if you have an existing Kubernetes cluster, which is properly configured with scalability, using autoscaling, etc., and you want to utilize that, plus maybe you want to use some cluster internal resources in your jobs, you can use the Kubernetes executor. And with Kubernetes executor, a new Kubernetes pod will be created as an environment to run the job. You also have a Docker machine executor. So Docker machine is basically a tool for scaling and managing Docker environments. It was created by Docker itself, and according to Docker's official documentation, it lets you create Docker hosts on your computer, on cloud providers, and inside your own data center. It creates servers, installs Docker on them, and then configures the Docker client to talk to them. So it's like an abstraction or managing layer over Docker itself, so you can manage multiple instances of Docker on a machine. And the Docker machine executor works pretty much the same way as Docker executor. Now it's interesting to know that this is an executor type on GitLab's shared runners. So I mentioned that GitLab has the runners that it manages for you, and those runners are using Docker machine executor. However, note that Docker machine has been deprecated by Docker, so GitLab will most probably replace it with another executor type on its shared runners. Now there are two other executor types, which are SSH and Parallels, which you won't actually need in most cases, so we won't go into detail here. They're actually not interesting for us. Now the question you might have now is, which executor type should you choose? Well, each one has its own use cases, and generally speaking, for most cases, for building the standard CI/CD pipeline, Docker executor on Linux runners is probably the best option. However, as I said, you may have some specific use cases. For example, if you need an operating system specific environment, then you can use the shell executor and execute jobs on Windows and Linux on the operating system level. You might also have a case where you want to have everything in Kubernetes because you are managing the whole infrastructure using the Kubernetes cluster, and you want to take advantage of that and also execute your pipeline jobs within the Kubernetes cluster. Now, how do you define and configure which executor a runner uses? Well, when you register a runner, and we will see how to do that in this course, you have to define an executor. So you as an administrator, when you're creating and configuring this runner, you have to say, I want this runner to execute jobs using a Docker executor or a shell executor, etc. And you can define only one executor per runner. Now, what if you need multiple executors on the same host or the same server? Like you have an EC2 instance as your GitLab runner, and you want to execute jobs in shell executor, but also Docker executor, because you have several jobs and some of them are best executed in a shell executor and some of them are best executed inside Docker containers. So how can you use the same server, physical or virtual host, to do that? Well, for that, you can actually register multiple runners on the same host. So you can have one machine with 10 runners registered on it, each one with its own executor. So now we've seen all parts of the GitLab architecture. We have the GitLab server or GitLab instance, we have the GitLab runner and the executor. So now the overall architecture of GitLab setup and the execution process will look like this. First, the GitLab runner will pull new jobs from GitLab instance. For example, a managed GitLab instance from gitlab.com. Once it has this job, the GitLab runner will compile the information and send the job's payload to the executor. The executor will download the source code of the application directly from the GitLab instance and will execute the job, which can be again running unit tests or building a Java artifact file or building a Docker image, etc. So you need a source code of the application for that. So executor will download the application source code, so it has all the files available in its execution environment, and then execute the job that it received from the GitLab runner. Once the executor is done executing the job, it will return the output of the job to the GitLab runner, and GitLab runner will then notify what the executor provided back to the GitLab instance. So that's how the whole workflow works. And in our course, we will see the usage of Shell and Docker executors and see this whole workflow in action. So I hope you are really excited to get into it. And first, let's go back to our simple pipeline that we executed on GitLab CI/CD. And the question here is, which runner and which executor was used to execute our pipeline jobs? And how can we even see that information? As I mentioned, GitLab CI/CD by default offers the shared runners, and when you execute a pipeline like we did, one of the available shared runners are selected for each of the pipeline jobs. So these are runners managed by GitLab itself, as I mentioned, called shared runners, and they're using Docker Machine Executor. And as I said, it will probably be replaced sometime in the future because the Docker machine got deprecated. And when that happens, we will actually update the course to give you the new up-to-date information. So let's actually now go ahead and see which shared runners executed our jobs. How can we see that? Very easy. We have that information in the job execution logs. So if I click on one of those jobs, the first part of the logs actually displays exactly this information. So the first line, which says running with GitLab runner, and then the name of that runner. So this is the identifier or the name of the runner where the job was executed. So we have this information here. Then we have the executor type that was used to run this job. And as you see, it's Docker machine. And this means that just like with Docker executor, the job will run inside a Docker container. And this is actually information about which Docker image was used to build that container and execute the job. And we have Ruby 2.5 as the container image. And as you see here, it's pulling that image on that runner, preparing the environment for the job execution. And once the container is ready, the application source code is downloaded from the Git repository inside the container, and all these commands inside the job definition get executed. And after the job commands get executed, the environment gets cleaned up, and the Docker container that executed this job is being destroyed. So at the beginning, a new Docker container was created to execute the job, and once the job is done, the container is destroyed. And also important to note that each job may actually get executed on a completely different runner. So just because they belong to the same pipeline doesn't mean that all the jobs in the pipeline get executed on the same machine or the same runner. And that is actually a very important concept. And we're going to come back to that later in this course. So again, if I click on one of the other builds, you may see a different runner that executed that job. And with Docker machine or Docker executor, every job will run in a fresh new container, which isolates each job execution and even allows you to use some sensitive secret data in your job environment without sharing it across jobs or projects. Now let's see two more things that are interesting here. First of all, let's see where are those shared runners that GitLab manages and makes available for us actually listed or displayed, or can we even see them? Right now we are in the CI/CD tab of the project, right? So this whole section here. And our project CI/CD also has settings. So we have this settings section at the bottom, which, if you remember, is where we configured the variables. And one of the settings is for the CI/CD. So here we have the administration part, so to say, of the repository, of CI/CD and other stuff that we have in a user view here. So this is where we can administer all this stuff. So if I go to CI/CD, and again, this is where we configure the variables. And here we have the configuration settings for runners. And let's expand that. And you will see a list of shared runners which are used to execute the pipeline jobs. With no configuration or setup and so on from our side, which is awesome because we were able to get started building our application pipeline without any administrative effort. And again, since this GitLab.com platform is one GitLab instance, all the projects on GitLab.com can actually use these shared runners. And that's why they're called shared. And as you see, we have a list of multiple runners, but in practice, we actually don't really care which ones will be used to execute our jobs, which is again good from a user perspective because we simply define what the job should do, what commands it should execute, and as long as that runner that gets selected knows how to execute the commands in the job, we are fine. And going back again to the runners configuration, we also see a configuration part for another type of runners, which is called specific runners. And this is an empty list because there are currently no specific runners for the project. So these are basically the runners that are for this specific project. So none of the other projects on GitLab.com can use it. This is only configured to execute pipeline jobs of this project. And in the case of GitLab.com installation, it can be used to register self-managed or private runners that only your GitLab projects can use and won't be shared or even displayed to other users on GitLab.com. And we will actually do that later in this course and learn how to configure specific runners, which is actually pretty simple. We will register 2 specific runners and make them available for the project. So we will come back to this part a little bit later. So the runner configuration or settings part is the one thing I wanted to show you. The second part is related to the Docker machine executor. And we saw in the logs that an image of Ruby 2.5 is used to create containers for executing the jobs. Now the question is, can we configure a different Docker image for a Docker or Docker machine executor? So basically, can we choose which image will be used to build containers? Because as I said, a big advantage of using Docker executor or Docker machine executor is that you can actually use a ready image that already has a tool like NPM or Node or Java installed on it, and basically use that to run a job that needs that specific tool instead of having to install and configure them on the server directly. So if I wanted to run an NPM command, how do I choose an image that has NPM inside? And can we override it here for the shared runners? Well, we can actually specify or override the default image that is used here, and we can do that inside our pipeline configuration, which is great because we also have that information inside our pipeline logic. So we have that documented here as well. And we can configure a Docker image in a very simple way, just specifying image attribute and whatever image we want to use. So let's say we want to execute some npm command. So let's find a latest Node.js image that will have npm command inside. And I'm going to choose 17 Alpine version of the Node image. And there you go. So this now means that every single job because GitLab uses Docker Machine Executor on all its shared runners, every job will be executed in a container. And for every single job, this image will be used to execute them. And that's it. That's the whole configuration. And as I mentioned, the advantage here is that we have that information also in the pipeline logic, so it serves kind of like a documentation. So just by looking at your pipeline code, you know exactly which image you're using to execute your jobs, in addition to the job logic. So let's actually commit our changes and see we're in the main branch, so it should build the whole pipeline, and let's see the output. So let's go to the pipeline and just click in one of the jobs, doesn't matter which one. And right here, you see that instead of the Ruby image, the Node.js image was used. And the same image will actually apply for each and every job in the pipeline. Again, let's check the deploy job, and you see Node 17 Alpine. And now let's say we want to execute some npm command in one of our jobs, and we should have npm command available because we're executing each job in a container with Node image. And we're going to test with a very simple npm command. We're going to print out npm version. So let's commit the changes, let the pipeline execute, and we're going to see the outcome. And as a shortcut, I can actually directly go to the jobs by clicking on the stage and the job itself. So run unit tests, that's where we are printing the npm version. So let's go inside, and there you go. So npm version, first of all, the Node image was used, and here we have npm command available that basically just prints the version. And now to demonstrate without the Node image, let's comment this out. If we try to execute an npm command in a container with a different image like Ruby, we will have a failing job, right? Our job failed because the npm command was not found. And this is how much flexibility Docker or Docker Machine Executor, because we can use any image that we want with a pre-installed tool, and then we have that tool or command available for our job, which is amazing. And on top of that, we have that information of which image is used for the execution documented in the pipeline code. Now, one thing I want to note about the image specifically and how we specify an image is the best practice when specifying an image is to always use a specific version. So we could theoretically do this and just use a Node image or a latest Node image. But in this case, with every single execution, always the latest Node version will be fetched. And this makes it unclear and not transparent exactly which Node version we're using. And also there could be a change in the image that breaks our pipeline. Or it could also be that our project needs a specific npm or Node version, so we have to fixate the version. So the best practice is to always use a specific tag, and the more specific, the better. So for example, we could take this one, and we know exactly which version is used, and our pipeline execution will be always the same because it's using the same image version. So this way your pipeline stays consistent and easily migratable. So you know exactly which version you're using and a transparent documentation in your code. Now you're probably thinking, maybe you don't want to execute every single job in the same container with the same tools installed in them. For example, we have this JavaScript unit test where you need npm, but then you have build image where you need Docker, or you have this deploy image where you need something else. So in that case, ideally, you would want to have image specification per job, and you can actually do that as well. So instead of globally specifying which image to use for your jobs, you can specify them simply on a job level. So right here, you can say, I want to use image whatever, and for the rest of them, you can either also configure some different images, maybe this needs some other tool, doesn't matter, and specify a different image, or if not specified, they will simply use whatever the default image is for the Docker executor or Docker Machine Executor environment. Or we can use a combination of them, and we can say by default we want to use an Alpine image, which is a lightweight Linux distribution, basically. So let's say we want Alpine 3.15.1 specific version for all the jobs, but for unit tests, we need the node image. So let's actually try and execute with this configuration. And let's go to the pipeline. First of all, let's check the unit test job. We have this node image that we configured, and npm version was successful. And let's check one of the other jobs like build image, and we should see the Alpine image that we globally configured for the rest of the jobs. So you have this kind of flexibility as well. Now, one more interesting thing is that let's say you have this image configuration defined in your pipeline. However, your job gets executed on a runner that doesn't have Docker or Docker machine executor configured on it. Let's say it uses a simple shell executor. So what happens in this scenario? In this case, the image configurations will simply be ignored and the job will be executed on a shell executor. So that may be also interesting to know. Now let's say you and your team want to have separate runners dedicated to your project only. You don't want other projects' pipelines to mess with it or use it. So if a company has multiple project teams, one team may not want to share runners with other team and their projects, and instead have their own isolated environment for running their project jobs. And there could be many reasons for that, just isolation for resources, security, and so on. And for that, we have this other type of runners called specific runners. And we saw that quickly in the GitLab CI/CD settings section. So specific runners are project specific. When you create them and register them, you can connect it to a project and make it available for specific projects and make it available for only those projects. So other projects that are also part of the same GitLab installation, which the specific runner is registered with, cannot use these specific runners. And you can actually have one specific runner dedicated to one or more projects. But again, you have to make that connection, or basically unlock that runner and make available for each project explicitly. And while shared runners on GitLab.com are managed by GitLab itself, the specific runners will be self-managed. So if I want to configure specific runners for my projects on GitLab.com, then I have to manage them, create them, and so on myself. So these are self-managed runners. And this means I will set up the machine, install a GitLab runner program on it, and connect it to the GitLab server instance. And now I have my self-hosted runner. And it's actually pretty simple to do. So we're gonna create our own specific runners in this course. So while the GitLab server itself is a complex software with multiple services, the GitLab runner itself has a relatively simple installation and setup process. And also interesting to note that you can configure a GitLab runner on any environment. This could be your laptop, local machine, or this could be any remote machine, could be any virtual machine on a remote cloud platform, and so on. And you can install a runner on any operating system. So once we have chosen a machine where we want to install GitLab runner and we installed the GitLab runner program on it, we then connect that GitLab runner or register it with the GitLab server for one of our Git projects. So the registering a runner is the process that binds that runner with a specific GitLab instance. And when you're registering a runner, you're basically setting up a connection between your GitLab instance, like gitlab.com, and the machine where GitLab runner is installed. And with this, we've come to the demo part where we're going to set up two specific self-managed GitLab runners, one on a local machine and one on a remote machine on AWS EC2 instance. And we will then use those two GitLab runners to execute the jobs in our pipeline. So let's get started and set up those runners. In this section, we will learn how to configure your own runners for GitLab and install any tools we want on them to use it in the pipeline. So let's see what we will do exactly. First, we will configure a local runner either on a macOS machine or a Windows machine. So if you have macOS, you can follow the guide for installing GitLab Runner on macOS. If you have Windows, then you just go to the video about GitLab installation on a Windows machine. And this local runner in an actual real-life use case can actually be for testing purposes. Plus, many companies also have Windows servers, so you may need to configure a runner on Windows machine so you can also learn how to do it. And in this course specifically, it's good for learning purposes if you don't want to spend too much on the infrastructure costs. So this will be our first runner. After that, we will go to AWS and create an EC2 instance, or basically a virtual server with Ubuntu operating system, and we're going to configure a GitLab runner on that machine. And this is a more realistic scenario where you configure a remote runner on a Linux machine to connect it to your GitLab instance. And I chose Ubuntu so that you can create a server on any other cloud platform or server or a virtual machine. And as long as it's an Ubuntu server, the installation will be same. So again, if you have your own server that you're using that is an Ubuntu machine, you can use that instead of the EC2. Now, very important to note here is that when we use AWS services, like EC2 instance, for example, you will have to pay for that service. So you will be charged for what you use. This is a compute service, so on any cloud platform, you have to pay for these compute services or virtual machines that you use for your projects. And if you want to reduce the cost, you can actually stop and start the instance in between the learning sessions. Because on AWS, currently at this moment, you are not charged for an instance which is not running. And of course, when you're done with the course, make sure to stop and maybe even delete the instance to avoid any further costs. So with that, let's go ahead and configure local and remote runners. In this video, I'm going to show you how to install and configure a local GitLab runner on a macOS machine, which is super simple. And GitLab actually has a very good documentation on how to install a runner on any type of environment. So if you simply Google GitLab runner on macOS, for example, you have the docs here. Let's make it bigger. And right here, you have the install GitLab runner section with installation part, and for every single environment, including Docker and Kubernetes, Linux, macOS, Windows, you have own guides. And you also have multiple ways of doing it. We're going to choose the easiest way, which is using Brew as a package manager on macOS. If you don't have Brew installed yet on your macOS, simply go and install Brew. It's also super simple. Just execute the command that you see, and that's it. So with Brew installed, we can execute one simple command, which is brew install GitLab runner, and that will install the runner. So I'm going to copy that and go to my terminal on my Mac machine, and I'll do brew install GitLab runner, which is a package that will be downloaded and installed. And there you go, the GitLab runner was installed. Now we just have to start the service basically using brew services start command. We have successfully started GitLab runner, and now we can actually validate that GitLab runner is running, and we can also see the version using GitLab runner commands. Let's clean this up. So GitLab runner minus version will give us the version of the GitLab runner that we have installed. And with brew services info command and the name of the service that we have started, we can check the status, and we see that GitLab runner is running and loaded. So everything looks fine. We have basically installed GitLab runner locally on our Mac. However, our GitLab installation itself, so my GitLab account and the projects that I have here doesn't know anything about this GitLab runner, right? We just installed a program on a server. It's not connected to the GitLab.com installation. And if you go to the settings of the runners and expand it, we have an empty list here. So we basically have to connect our runner program that is running. We have to connect it to GitLab installation so that we can use it in this project. So how do we do that? Also very simple. It just takes one command, which is GitLab runner register. And if I return this, first of all, I get information about the GitLab runner. And here are a couple of details that we have to configure for this runner in order to connect it to the installation. First of all, it is asking us which GitLab instance do we want to connect it to, right? So if a company has its own GitLab installation, then obviously you will have the URL of your GitLab installation. In our case, that's the URL, which is gitlab.com. That's our GitLab instance. So I'm going to copy that because we're connecting it to gitlab.com instance. Again, return. And now it's asking for a registration token. And again, going back to project CI/CD settings, in my project, I have this token, the registration token, which I can use to register any specific servers. So I'm simply gonna copy that and enter it here, return. Now we just have to configure a couple of metadata about the runner itself. So first of all, description for the runner, let's actually call it a local runner. Then we have to enter tags for our runner. Now this is very important and we're gonna see why, but in our case, let's actually just enter some descriptive tags. So first of all, we want to add a tag that says it's a macOS runner, and let's also add a tag called local. So we know it's a macOS installation and it's a local runner, right? And you can add as many tags as you want. We're just gonna add these two and return. Optionally, we can add some additional notes. For example, we can say this runner uses shell executor. And if I return, now we have to actually choose an executor. As we already learned in the executor section, we have different types of executors that we can configure for a runner, and each runner can have exactly one executor. And this is the step where we decide which executor the runner is going to use. And also, as I mentioned, in this course, we're going to use two executor types. One of them is shell, and the other one is actually Docker. So for the local runners, we're actually going to choose the shell executor. So type it in there and return, and that's it. Runner registered successfully. It is already running. You don't have to reload it. And now let's actually go back to our GitLab CI/CD settings and reload it. And right here, we see our local runner. So that's the description that we gave it. And these are the two tags that we configured for it. We have the local tag and macOS tag. So now we have one specific runner available for our project. And if I click inside, you see a bunch of information. It tells you which platform or operating system it is, and so on. In this video, I'm going to show you how to install GitLab Runner software on a Windows machine. So let's go and open our browser, open Google, and let's type GitLab Runner Windows. And you will see the link to the official GitLab documentation with the installation guide. And you will see in the installation section of the guide a couple of steps we need to do. First, we need to create a folder called GitLab Runner somewhere on our system. For example, in the root of our C drive. And the reason for that is that we're actually downloading an executable of the GitLab Runner software. So let's create that folder in the location they are suggesting in the documentation. So let's open the File Explorer, go to this PC, select the local disk C, and inside that, let's create a new folder called GitLab Runner. There you go. In the second step, we're going to download the actual binary. In our case, we are on a Windows 64-bit machine, If you're on a 32-bit machine, you can download that one. So let's click on it. It will start downloading the executable. If you receive this download warning, it basically means that your browser is telling you that you're downloading an executable file and that it may be risky. If you don't completely trust the source or you don't trust the executable file itself, etc. So your browser is trying to warn you. In our case, we know what we're downloading. It's the official source from GitLab, so we can tell browser to keep the file. Show more, keep it anyway. Once it's downloaded, let's open the folder. Let's grab that file that we downloaded and move it to the GitLab Runner folder that we created in the C drive. So GitLab Runner and paste it here. Another recommendation is to rename this file to just GitLab Runner without Windows and the 64-bit in the name, because that's going to be the file that we're going to execute to run the commands. So let's rename and leave the name simply as just GitLab Runner. Now the next step is to open your terminal. This can be either PowerShell or the Windows CMD command line program. In our case, let's click on Windows and type CMD, and we need to run it as an administrator because we're going to be installing the GitLab Runner software. So go ahead and click on Run as Administrator. It will ask us for extra permissions, click Yes, and now let's navigate to the location where we have the GitLab Runner binary file that we downloaded. Go to the root of the C drive and go to GitLab Runner folder. And if I list all the files inside, there you go, we can see the executable file. Now let's clear all of this with the CLS command and let's execute that binary by calling the dot to represent the current folder, then backslash and GitLab Runner, which is the name of the file, and we want to say install. So this will execute the GitLab Runner binary with the install command. And there you go, the service was installed. Let's now run the binary with the start command to start the GitLab Runner service. And there you go, GitLab Runner service is now running. We can verify that with the status command and it says service is running. Great, so we have GitLab Runner service up and running on our Windows machine. As the next step, let's register this runner with the GitLab instance. Registering the runner from Windows is the same as on Mac or Linux. We simply execute the GitLab Runner register command and it will ask us for some values, just like on those other operating systems. So first value is the GitLab instance URL that we're connecting to. And we're going to use that default suggested value, which is gitlab.com, because that's the instance that we're connecting to. Then we have the registration token, which we need to get from our GitLab project. So let's go to our project's CI/CD settings, expand the runners, and copy the registration token. Let's go back to the terminal and paste the token there. Next, it will ask for description of the runner. This description will appear as the runner name in the GitLab UI when we register the runner. And let's call it Windows Runner. And now we need to assign some tags to our runner. We'll see why the tags are needed later when we use the runner in our pipeline. You can add any tags here that somehow describe the runner. I'll add Windows and ARM. We don't need the optional maintenance note, so we'll skip it. And finally, an important configuration of a runner where we define which executor this runner will use. And let's configure our runner with the shell executor. And there you go, our runner is now registered. Now, if we go back to our GitLab project CI/CD settings, refresh and expand the runner again, we should see the newly registered runner on the list. And as you see, it's already green, which means it has successfully connected to the GitLab instance. Now, if it's not green for you right away, don't worry. It may take a couple of minutes sometimes for the runner to connect to the instance. And basically that's how you install and register a GitLab runner on a Windows machine. For this course, you're gonna need an AWS account. And in order to create an account, you basically just have to fill out some forms, including your address information, credit card information, and so on, because AWS wants to make sure that people who are creating accounts are verified and are registering with valid data. And I will put a link below for a guide of how to create an account that you can follow. And once you have an account, you get a free tier offer from AWS. So what does that actually mean? On AWS documentation, you have this free tier page that basically lists all the components, all the services of AWS that you can use for free for 1 year after registering an account. And some of them, or some of the most important ones, are the EC2 instance, which is the virtual server, which we're going to be creating on AWS, as well as some storage and so on. So you can take advantage of that free tier account on AWS. Now, by default, when you create an account on AWS, you have a root user. This user gets created automatically, and this user has access to all the services and all the features. So it has unlimited privileges to do whatever you want in your account, including the billing part, account settings, and so on. So the first thing we want to do when the account is registered is create an admin user that has less privileges than root user, but it will have all the privileges that we need to create EC2 instance, deploy some applications on that. And this is the first thing that AWS also advises to do for security reasons. So if you go inside the IAM service, you will see the configuration dashboard. So we can create users, groups, and permissions here and manage all the stuff here. Now, admin user can also have permission to create users, assign roles to them, and so on. So you can have one admin user to manage and administer the whole AWS account, but it will still have less privileges than the root user. For example, it will not be able to access the billing and credit card information. And then using that admin user, you can actually create other users and give them other permissions for team members. For example, if you have a DevOps team that all use AWS and configure stuff on there, obviously you need to give them all permissions and access to EC2 and maybe some other services. So the admin user can be the one that administers all of this. So now let's create a user admin that has admin privileges to do stuff on AWS services. We don't need a group for that because it's just going to be one user and the only one with admin access. So let's create it. So here we have an add user button. Let's call it admin. And we can give a user two types of access. It could be either access through the console in the UI. So basically you can log in on the UI and then do stuff through the UI, like configure stuff, change stuff, and so on. And you can also have a programmatic access. This is when you can execute different tasks from your command line. And this can be either through AWS command line interface, or in our case, we're going to use Terraform commands to access AWS. So we need programmatic access for the admin user to execute Terraform commands. And you can decide whether a user has one of those access types or maybe both. In this case, we can give admin both types of access because we want to be able to access the UI console with it. So we want to be able to log in with this user, but also execute things from command line. And as you see, the management console access displays some other options. because if we are going to log in with this user, we need a password for the user as well. And we can let it auto-generate a password. And with this option, we can force the user, the admin user, on the first login to reset their password. So the UI access will basically be through username and password. Username here, password auto-generated. And the programmatic access will be the keys. So from the command line, we're gonna need access keys or secret access key to log into AWS and then execute some commands. Let's go to next. Now here we can create a group that the user can be part of. It is actually the best practice to have all the users in a group and then to assign the permissions to the group rather than directly to user. But the admin user is going to be the only one in the group, so we can actually skip creation of group. So we can assign a permission to the user directly. And for that, we are going to go to attach existing policies directly. And this is a list of all the permissions or all the policies that we can choose from. And this is a pretty long list because you have granular permission policies in AWS. So you can basically decide for each single service what type of access you want to grant a user. And this actually is good because it supports the best practice of giving the user the least privilege they need. So if a user needs the read-only permission for a service, you can give a user read-only permission rather than full access. So admin user is gonna get administrator access, which basically includes all the policies and all the permissions that are needed for administering your AWS account. So we're going to choose administrator access policy and go to the next page. You can also add tags to the user, which is basically additional information like metadata about the user. If these are individual team members in your organization, this could be an email address, description or job title, name, surname, etc. It's optional though, and we're going to skip this for admin user. And next, and this is our summary page. So we have created an admin user. We're giving it access to login through a web console. The password will be generated, as well as programmatic access from the command line interface. And it has administrator access privileges. So all the permissions it needs to administer the AWS account. Let's create the user. And here you have all the information, all the secret information as well for the user. So password, you're going to need this one to log in to the console. And these two are the keys to access the AWS account and the services from admin user from your command line. So save all this information and those keys securely. So download this file and we're going to reference that later. And as a next step, we're going to log into UI using this password and change the password because we have configured it this way. So let's sign out as a root user and log in with the admin user again. Log back in. And in the sign in page, you have a selection between root user and IAM user. Let's choose this one. The ID or account ID of your user is also in this downloaded file. If you open it, in the console login link, you have this ID here. You can use a link directly to go to the login page like this. And this ID is going to be filled automatically. So this is the account ID. And here you have the username. We called it admin. And the password, which is also in this file. And since we've configured it, we have to change the password. And as you see, we're logged in as admin user And we can configure services and do stuff now with admin user. A quick note here that AWS is actually changing the UI very often, also in real time for different users. So the UI that you are seeing in my video can actually be different from what you are seeing right now, but most of the structure should be the same. So for example, if I go into EC2, you see that I have this toggle new EC2 experience enabled. So a couple of things have changed in this UI and it may look different from yours. So do not get confused by that. It may happen pretty often. In this video, we're going to go through and understand what VPC and subnet resources are on AWS, as well as Internet Gateway resource, security group, and so on. If you already know these resources, then you can skip this video and go to the next one. Now, whenever you create an account, in each region, you will have something called a VPC. So VPC actually stands for Virtual Private Cloud. So if you go through the services here, all services list, in the networking and content delivery part, we have this VPC service. And right now I'm in the Frankfurt region. And here you see I have a VPC, a default one that gets created with some other configuration as well. And if I switch to another region, for example, Europe, Paris, here I also see a VPC. So I haven't created any of this. This is out of the box by default in each region. So VPC in AWS is basically your private network, right? When you create resources, virtual servers, and so on AWS, you obviously don't want other AWS users or other AWS accounts to have access to your resources, right? You want to protect them and you want only you to have access to them. So because of that, you can create this virtual private cloud on AWS infrastructure that only you have access to. And you create this VPC in a specific AWS region. So again, region is basically one of those regions in a list. So for example, in Paris region in EU West 3, I can create as many VPCs as I want. However, region in AWS consists of multiple availability zones. Availability zone, in very simple words, is basically a data center of AWS with all those servers that runs the whole infrastructure. So the virtual machines that you spin up in your AWS will actually run in one of those AZs, because these are the actual physical locations where the servers will run. So VPC will actually span all the availability zones in that specific region. So here you see Paris has 3 zones and VPC actually spans all of these 3 zones. So in each region, basically VPC isolates a space where you are creating your virtual instances, your servers, maybe database instance, some other components from different services, because obviously this is a data center where others also rent virtual servers, create components, so they might actually be running on the same physical machine, same computer, but they will be isolated in private networks with VPCs. And for bigger corporations that have much more complex application setups, they can actually use multiple VPCs and manage multiple of these private networks in different regions. Now, what does this VPC include? Here you see we are in the VPC dashboard and we have a bunch of other stuff in here. It is basically a virtual representation of network infrastructure. When you have servers physically in your company, which was a traditional way of hosting servers and applications before cloud, you have sys administrators that set up, configure, and manage this whole network. They set up the router, they do all the network configuration, configure firewall, and so on. So all of this physical network infrastructure is basically now moved in cloud, and VPC is the representation of this. And the reason why you have this default VPC in each region is that whenever you create an EC2 instance, it has to run inside a VPC, or whatever component you're launching, it has to start inside a VPC. Another thing you see here is subnets. So we have 3 subnets, and subnets are subnetworks. So VPC is the whole private network, and subnets are basically components or subnetworks of the VPC. While VPC spans the whole region, all the availability zones, subnets span individual availability zones. So for each 3 zones, you'll have their own subnet. So it's like a private network inside a network. Another interesting thing in the VPC part is that obviously whenever you create a virtual server, it has to get an IP address. And in VPC, you have a range of private or internal IP addresses. And that range is actually also defined by default, and you can even change it. So if I go inside VPC, here you have a range of IP addresses. So whenever you create a new instance, a new EC2 instance, an IP address will be assigned to it from this range. So internal or private IP address is not for internet traffic, but rather for traffic inside the VPC. So when you have multiple servers, multiple components inside the VPC, they need to communicate with each other, right? So you have an instance with web application, another instance with database application, maybe a third one with some other service. They all need to communicate. So private IP address is what allows them to talk to each other. So the IP address range is defined on a VPC level, and then each subnet then gets its own IP address range, the private IP address range, from that total range, right? Gets like a sub range, so to say. And here you see those sub ranges defined. Now, obviously, when we deploy our web application on EC2 instance, we want it to be accessible from internet, right? From outside. And for that, in addition to private IP address, we need to assign it a public IP address. And this is also configured in VPC service. So when we create an EC2 instance, it will get a private IP address from the range of the subnet inside which that instance will start, and it will also get a public IP address. Internal one for internal communication inside the VPC, and a public IP address for accessing it through the browser. For allowing internet connectivity with your VPC, you also have an internet gateway component. So this basically connects VPC to internet, to the outside world, so that you can get traffic inside your VPC to your web servers, for example, and then you can also send traffic outside if you want to download some stuff from internet on your components, etc. Now, obviously, in addition to all of this network configuration, you need to secure your components, right? So for example, you want to control what traffic enters your VPC or what traffic reaches individual instances and components in your VPC or in your subnets, and you want to control what traffic goes out, right? So this is a firewall configuration basically for your VPC and for individual instances. Now you can configure that security control on multiple levels in VPC. And AWS makes it actually pretty flexible and granular of how you can configure all of this stuff, not just security, but the IP address ranges, the route tables, and so on. And that's why you have this pretty big list of things that you can configure. However, in many cases, you will not need some advanced network configuration. Most of the stuff is configured by default, as you see here, because you have these components already created and configured with some default configuration. And in most simple applications, you will not need to do any crazy configurations here. And since this whole network is private and by default closed to the outside world, so no access from internet, of course, for your web applications, you want to configure some internet access, right? As well as you want to SSH into your servers from your laptop. So you want to configure some kind of external access. And for that, you have components inside that VPC service called network ACLs, which are basically firewalls or firewall rules for subnets. So you can configure this per subnet. And in addition to that, you have security groups, which are, again, firewall rules, but on a virtual machine level. So inside the VPC, we have the subnet, and inside subnets, we're going to have EC2 instances, which are basically the virtual servers. And we can configure firewall rules on that virtual server level using security groups. So you create both of these components on a VPC level, and then you assign the NECLs to individual subnets and assign security groups to individual instances or components inside that VPC. Now we have one local runner that is connected to the gitlab.com instance. And depending on your operating system, this is either a macOS, Linux, or Windows local runner. Now we want to configure a second specific runner, which is going to be on a remote machine. And for that, we're going to choose Ubuntu distribution on AWS EC2 instance. And in the AWS prerequisite video, you'll learn how to set up an AWS account and the basics of creating and configuring virtual machines on AWS platform. So let's go to our AWS account. Note that your AWS UI may actually be different than mine, so don't worry about that. You can just search for any service you want. We're going to use EC2, and inside that, we're going to create a new instance. And we can do that simply using the Launch Instances button. Here we have a couple of operating system images that we can select from. And as I said, I want to make it as generic as possible so that you can actually use any machine anywhere you want, not necessarily on AWS. And that's why we're going to go with Ubuntu 20.04 version and create an instance from that. So I'm going to select this. I'm going to choose the one with free tier eligible tag. This should actually be enough for our use case, and everything else will stay default. So with all the default configurations, we're simply going to launch a new instance. So we don't have to do much here. You can directly go to review and launch. So click on it, and there you go. So again, the operating system image we selected. And one thing that is important for us is to have a security group configuration that allows access to our machine on an SSH port, because we're going to have to SSH into that server in order to install the GitLab runner and anything else that we need, right? So make sure that this port is open. Now, this configuration opens it for any IP address, but you can limit it to your own IP address if you want. You can do that using this edit security group configuration. So basically just type in your own IP address so only you have access to it. I'm just going to leave it at that because this is just a test instance. So I'm going to delete that later. And if I click on launch, we're going to have to do one more thing. And that is create a key pair, which is an SSH key pair for our instance. And we need that because, as I said, we're going to SSH into our server in order to install any packages and tools we want there. And in order to access or authenticate with the server, we need private public key pair for that instance. And then we're going to log in or SSH into the server using the private key of that key pair. So here, select create a new key pair. Let's give it a name. Let's call it GitLab runner key. choose the RSA option and click on download key pair. So this will download that PEM file locally. And once we have that, we can launch the instance. So now we have the instance that is being created. It's in a pending state. It has port 22 open, so we can SSH to it. And we have the key that will allow us to authenticate with the server. So it's in the running state. Let's also wait for the status to become running and fully initialized. And then we can SSH to it. So we have a status check that says fully initialized, 2 out of 2 checks passed. So now let's SSH into our server and install the GitLab runner on it. And you can actually get the full SSH command for connecting to your instance by clicking inside and then clicking on this connect button. So connect button shows you an example of how to connect to your instance. So this is the public DNS name and this is the private key name that we configured. And the default user for connecting to our Ubuntu EC2 instance is Ubuntu. So we can actually copy this and paste it here. We're going to have to make a couple of adjustments. First of all, let's locate our GitLab runner key, which is in the downloads folder. In my case, in your case, it could be different. So I'm going to configure the correct path. So it's downloads. And we actually don't need the quotes, so I'm going to remove that. So that's the correct location. Then, as I said, Ubuntu is the default user, and this is a public domain name of the server. And you can also check that if I go back to the instance of my running instance. In the details overview, so to say, you have public IP address as well as public DNS name, right? So this is the one we're using. As an alternative, you can also use just the public IP address. So I can actually copy this and use instead of the DNS name, and this will also work. Now let's actually try to execute this command and see what happens. So we have the authenticity confirmation request, let's say yes. And now we get an error that says our key is unprotected private key file. So the problem is that the PEM file or the private key file that we use for SSHing into the server needs to have limited permissions. So not everyone should be allowed to have access to it. So right now, if we do -L, you see that everyone is allowed to read this file, right? So we need to actually remove that permission and make it available only for the owner. And to do that, we're gonna set the mode of that file on 400. So we are giving 0 permission, so no read permission to anyone else other than the owner. And again, if we check, only the owner is able to only read the file. So this is limited enough. Now if we repeat our command, our SSH command, we should be able to enter the server. And there you go. We are now on AWS EC2 machine with Ubuntu user, and this is the private IP address of the server or private domain name of the server. You can also check that. Starts with 172, ends with 114. And there you go. So that's the private DNS name. So we are on a fresh new Ubuntu server. The first thing, always, whatever you're doing or configuring, the very first thing is to do apt-get update. So let's do apt-get update before we install anything. And now let's actually see how to install GitLab runner on an Ubuntu machine. For that, I'm going to switch back to the documentation. And as I said, inside the install section, we have a guide for each type of environment. We have Linux, but we also have official Linux packages. So let's actually go inside this one. And here we see how to install GitLab runner for Debian, Ubuntu, or Mint, as well as Red Hat Enterprise, CentOS, and Fedora. So we're using Ubuntu. this is the command for us. And again, usually when you're configuring this stuff, you should always reference the official documentation, the up-to-date documentation with the latest version, and basically follow the installation guide they offer here, especially if something changes. So let's actually follow this guide. Let's copy this whole command and execute it here. Once that's done, we're going to move to the second step, again for Ubuntu, which basically installs the GitLab runner, just like we did with brew install, for example. So let's copy that and execute it here with sudo command. And there you go. So GitLab runner was installed. Here you have an option for installing a specific version. We just installed latest. So that's it. We have GitLab runner installed. And the same way we can check or validate using GitLab runner version command and check which version we have. And we can also check the status of our GitLab runner. And here we see service is running. So the first part is done. GitLab runner is installed. Now we need to register our runner. So let's do GitLab runner register. And we need to execute that using sudo. And there you go. So now we have to provide the same type of information. First of all, GitLab instance that we're connecting to. And here you already see an example when connecting to gitlab.com. And that's the gitlab.com instance. So we can just copy and paste it. We need the same registration token. The description for the runner, we can call this one EC2 runner. And again, let's add some text, which basically describes this runner. So we can add EC2, AWS, and maybe let's add remote as a tag. As an optional note, you can add any special information for the maintenance that you want to see for this runner. So again, let's say the runner is using shell executor. You can also leave it empty, doesn't matter. And let's also configure this one with the shell executor. So I'm going to choose shell, and that's it. Runner registered successfully. We can again execute GitLab runner start command to make sure it's reloaded. And there you go. So now we should have a second runner in our project's CI/CD settings. So let's go to our project. Let's reload, go to the runners again, and there you go. So we have the EC2 runner, which is available, and we have the local runner, and each one has its own description and own tags. Awesome. Great, so now we have added 2 private runners to our GitLab installation, and we can see that they have been added to the project's list of specific runners. So now, when we run our pipeline, let's see how and where it gets executed. So let's go to the pipelines, and let's actually manually trigger it by just clicking on the Run Pipeline button. And let's see what happens. We're running it for the main branch, not providing any variables. We just run the pipeline. So it was successfully executed. Now let's go inside the job and let's check the logs for information about the runner on which the job executed. And as you see, it was executed again on shared runners that GitLab provides us with. And this goes for each and every job that we check. So all the pipeline jobs got executed on randomly selected GitLab's shared runners, even though we have configured project-specific self-managed runners. So these 2 were basically just ignored. And that's the default behavior. So by default, the shared runners will be used. However, we do want to use our private runners instead that we configured and not rely on the shared runners. So how can we configure that? How can we make our jobs run on our specific runners instead? Remember when we registered the runners, we added tags that are displayed here, which serve to identify specific runners and to basically differentiate them from each other. And we use exactly those tags to reference a runner where our job will be executed. And it's actually pretty simple. So we go back to our pipeline definition, and inside our pipeline configuration, for each job, we can actually define on which specific runner we want to execute them. And we do that by adding an attribute called tags, and then specifying all the tags of that runner. So that's how we reference a runner inside the job. So let's say we want to execute our jobs on the EC2 AWS remote runner, and these are the tags that we gave that runner. So this configuration will make run unit test job execute on our specific EC2 runner. And we can repeat that for each and every job like this. So go ahead and add this tags attribute in all your jobs. Now we have an additional configuration here that we configured for the Docker executor or Docker machine executor on shared runners, which is the image attribute, right? We have a global one and we have one specific one here. And as I said, if a job executes on a runner that doesn't have Docker or Docker machine executor, then this image will be basically just ignored. And since we're using a shell executor on this remote runner, that image attribute will simply be ignored. So we can actually remove that if we don't need it, and we can leave the global one. It will be ignored anyways. So with this configuration, let's now execute the pipeline again and see that our jobs get executed on our specific EC2 runner. So commit changes, and we have a failure in our pipeline, and let's actually see the reason for that. So let's go to run unit tests. And first of all, we see the runner information, and this is the name of our specific runner, EC2 runner. So we see that the job was executed here. We also see that shell executor was used, and the failure is right here on this line, npm version, which is logical because we don't have npm command available on our EC2 runner because we didn't install npm or Node.js on it. And this brings us to our next topic. Again, when we use our self-managed runners for executing the jobs, we need to make sure that any tools that this job needs have to be available there, right? So if we need npm in this job, we have to actually go and install npm on our runner. So let's go ahead and do that to fix our pipeline. So let's go back to our terminal. Let's connect to our remote runner, and let's install Node.js and npm. And let's do sudo apt update. And after that, we're going to do sudo apt install Node.js. Continue. So now we should have Node available. Let's also go ahead and install npm. Continue. And if we do npm -v, we should have npm command available. So any job that executes on this runner should have access to npm command. So now if we re-execute our pipeline, and let's actually trigger it again, run pipeline, it should build successfully. And there you go. So let's go to run unit tests. This is where we have npm version command. And first of all, you see it was executed on the EC2 runner, and you see that npm version command execution was also successful. And all the other jobs also got executed. If we check one of them, again, we see they all got executed on our specific runner because we referenced it using the tags. Now, we are using only the remote runner and not the local one. But let's say we have different tools installed and configured on these two runners. So let's say our EC2 runner has Node.js and npm installed on it, while our local runner has some other tools that we need for, let's say, building, pushing, and deploying an image. So we're going to distribute our jobs among the runners. So let's say these two will get executed on the remote runner, and the final 3 builds will be executed on the local runner. So let's change those tags and configure local. In my case, it's a macOS. If you have Windows, you can configure those tags. And let's execute again. So first of all, let's check that our tests got executed on EC2 runner. Both lint and unit tests, like this. And build, push, and deploy were executed on the local runner. And there you go. So using the tags, we have this flexibility of deciding which specific job will be executed on which runner. And using this approach, we can also share the load among the runners and basically send some of the jobs here and some of the jobs to another one. But let's see what are some other use cases for having multiple runners for the same pipeline and how it may look like in a real project. So first of all, let's say we have 20 runners in our GitLab setup that we're managing ourselves and we have connected them to the GitLab instance. We may want to configure each runner to do a different thing. For example, we may have a Windows runner with a shell executor, another Linux runner with a Docker executor, and some other runners with a Kubernetes executor. And if we have a job that needs to execute on a Windows machine or in a Kubernetes cluster, etc., we can send that job exactly to the runner that has everything configured for that. So this gives you a flexibility of how you can execute your jobs. Now, of course, in any setup, you also care about scalability. Like if you have a Windows runner for all your jobs that need Windows operating system and the server where that Windows runner is configured fails, any of your jobs with Windows runner tag won't have a proper runner to execute on. So usually you would have 2 or more runners of the same type with the same tags, and the job that references those tags will be executed on one of the runners. So this way you also have high availability of your runners and of your GitLab setup. However, if you have a simple pipeline for all your project and you don't need any special execution environments for your jobs and you're basically fine with the same exact execution environment, it's also common to have multiple interchangeable runners, like 20 Linux runners with a Docker executor, and all your jobs will be executed on the same environment. And in this case, you basically just have an advantage of distributing the load of job execution among all these runners. So both of these scenarios are completely valid and common in real projects. Now let's say we don't want to install and manage these Node.js and NPM on the runner's operating system directly. Instead, we want to execute it with Docker. So we will have the local runner, like macOS or Windows with shell executor, to run some operating system specific jobs, and the rest of the jobs should be executed in Docker containers on a remote runner. And this means we need to add a new runner with a Docker executor, so we have Docker executor environment available for our pipeline jobs. And as I said, we can actually add multiple runners on the same host or the same server. And since we have this EC2 instance already, with one runner currently with a shell executor, we can actually add and register another one with a different executor. So let's go ahead and do that. Now, before we can register a new runner with Docker executor, in our case, we need to first install Docker, right? Because the runner will have to create Docker containers to run the jobs, which means we need Docker available on the machines to create those containers. So instead of having to install all the tools like Java, NPM, or whatever we need for our jobs, we just have Docker installed, and everything else, all other tools will be available through Docker images. So let's first install Docker on our EC2 server. And if we do docker ps whatever, we get a command suggestion of how to install Docker. So we're going to do that. So we're going to execute this command. So Docker is installed. Now if I do docker ps, I would still get an error because I can't execute Docker commands using Ubuntu user. I can only execute it using sudo command. So let's do sudo docker ps. which means Docker daemon is running, so the service is running. However, we also want the Ubuntu user to have permission to execute the Docker command. For that, we need to simply add Ubuntu user to Docker group, and which is a very common thing. You can just grab the command online. So this is basically changing the user, the current user, which is Ubuntu, and adding it to a group called Docker. So let's execute that. And now if I log out from the server and log in again, I can execute the Docker commands using the Ubuntu user. There you go. So Docker is configured. Let's now register a new runner with a Docker executor. So we're going to repeat the same GitLab runner register command that we executed before, like this. So sudo GitLab runner register, and let's provide all this information. So first of all, we have the instance, which is gitlab.com. Then we have the registration token, which we can copy here, the description for the runner, and let's call it EC2 Docker runner. Let's add the tags, and note that these tags should actually be different than the ones that this runner has, because we want to differentiate them and make each runner specifically identifiable, right? Because they're different. So we're going to add EC2 tag, we're going to add Docker tag, and let's also add remote. So Docker is a tag that uniquely identifies this runner, which this other runner doesn't have. We can leave the maintenance node empty. And now we need to choose the executor type. And we're going to choose Docker, so this one. And for the Docker executor, we also have to choose a default image. And let's actually choose the Alpine image that we have configured here as a default, like this, and runner registered successfully. And let's again restart our runner. And there you go. We have a third runner with different tags. And for consistency, we can actually change the tags of this runner to include an executor type. So we know which type of execution environment this one has, and we can actually change the tags and some other parameters of the runners from the administration UI. So if I click on edit, here you have a bunch of options to actually change the information that we configured during the registration. So you can adjust the description, tags. So right here, let's add shell instead of AWS, save changes, and there you go. So now we have unique tag combination for each runner, so each one can be specifically referenced. So now let's actually adjust our pipeline and use the Docker runner to execute the npm command in the Docker executor instead of directly on the operating system. So going back to the pipeline configuration in our unit tests job, we're going to select the runner with Docker executor, and we change the tag of the other one and we call it shell. So this will be executed on an EC2 runner with shell executor. These other ones are executed locally anyways, and here we actually need a Docker image with npm command available inside. And we can use the one we had before, which was a node image with this specific version. So now, because we're using a Docker executor environment, this image tag will actually be applied and used to create a container in which the job will be executed. Let's commit the changes to trigger the pipeline. So the lean tests, they ran on EC2 runner with shell executor, and the unit tests should have run on the EC2 runner with Docker executor. And let's see that. There you go. We have EC2 Docker runner and Docker executor with image that we configured specifically for that job. And it took a little bit longer at the beginning because of pulling the image. And here we see that npm version was again executed successfully, this time within a container. And the other jobs, as we have configured them, were executed on a local runner with shell executor. So as you see, we have all this flexibility of what we execute where and how, using these simple concepts of tags and multiple runners. So GitLab CI/CD architecture is actually pretty simple but powerful, that gives you all this flexibility, which you can configure completely in your pipeline logic. Now we have configured 3 specific runners for our project, but let's consider this use case for our project, and each one of them are specifically dedicated to this one MyNode app project. And if I click edit for one of the specific runners, you actually have an option here to what's called unlock this runner for other projects. So for example, if you have 1 or 2 other projects and you need runners for those as well, you can actually reuse the same runner for those projects by basically just unlocking it here, so you can assign it to those projects. But let's consider this use case. Let's say we're developing an online shop application, and it is made up of multiple microservices. And we have a separate project or separate repository for each one of those microservices. And let's say it's made up of 20 of such small microservices, and each one has its own pipeline. Now we could unlock each one of those specific runners and assign it one by one to all these 20 microservices, but it sounds like too much effort and also kind of difficult to maintain. So for that use case, we actually have a concept of group runners. So let's see what group runners are and how we can configure them. First of all, in GitLab, you have projects. So these are individual projects that you can create for your application code. So individual repositories. And then you have what's called groups. So groups in GitLab are basically meant to group multiple projects, so multiple individual projects that belong together. Again, as I said, in your company, you may have multiple teams, and each one of those teams may actually have multiple projects. So this will be a really good way to group all the projects that different teams manage. And as I mentioned, this could be microservices for the same application. You may have some supporting libraries and custom frameworks for your application, or you may also have additional repositories or projects for infrastructure as code, like Terraform scripts, Ansible scripts that provision infrastructure for your application and then configure and deploy it on that infrastructure. And that's a really good way to group all the projects that belong to the same team. And it's super simple to create a group from the UI. And let's actually create a group, and we can call it my super online shop. We get a group URL, which leads you directly to the group, and you can decide to set it to private or public. You can add people to the group, etc. And let's actually create that group. And now within that group, you can create projects. So again, all your microservices will be own projects. Plus you may have infrastructure as code repository, library code, and so on. And the good thing about it is that you can also manage the access permissions for the whole group of the projects instead of managing the access for each individual project. So you can configure your team member permissions, access permissions on a group level. And again, coming back to the example of having multiple projects in this group for your online shop application, let's say you have a payment service, which is one microservice, you have a shopping cart, you have a checkout service. So basically all these individual repositories grouped under here, and you can configure CI/CD pipelines for all of them. And you may want to share runners among all these projects within the same group. So in the team, you may have one administrator that will configure all these runners for the whole group and then make those runners available for the projects in that group. And this will be group runners. So how do we configure a group runner? Before we saw that in our project, in this specific project, we had the settings for CI/CD, and we were able to register specific runners for this project. The same way in the group overview, in the settings, you have own CI/CD configuration. In the settings for CI/CD, you have runners. And if I expand this, you see the shared runners, which is the same as we had here. So these are the ones available from GitLab. And you have group runners instead of specific runners. So using the same process that we used here, you can actually very easily register group runners for the whole group. And they will be then available for all the projects in that group. And once you configure them, they will basically appear here. And you have a shortcut directly here that lets you see an overview of your group runners. And we're actually going to see a demo of creating a group with microservices and configuring a group runner for those microservices later in this course when we get to the microservices deployment. So here I just want to give you a more theoretical overview of what group runners are, how they're used, and how they compare to shared and specific runners. So we're going to see all of that in action later in this course in the microservices chapter. So till now we saw that we have GitLab software as a service instance where we can host our repositories and we can build CI/CD pipelines directly on that will utilize GitLab's managed shared runners. But in addition to that, we can configure and add specific and group runners, which we will manage ourselves, to that GitLab.com's instance. So we have our own runners that none of the GitLab users will have access to, and they will be specifically dedicated to our projects. But let's say in addition to managing the runners ourselves, we also want to run and configure the GitLab server ourselves. So the whole GitLab instance and the specific and group runners, this whole setup, we want to manage ourselves. And there are a lot of use cases for that. Maybe we have some special requirements, such as high security in our company. So you want an absolute isolation from all other GitLab users, and you need absolute control over your GitLab setup and the underlying infrastructure. Or maybe you want to automate this whole thing as part of your DevOps processes. Maybe you already have servers that you pay for, so you want to use them instead of paying additionally to GitLab. Maybe you just want to save infrastructure costs because GitLab managing this for you actually costs you some money. So as you see, there could be many reasons why you would want to have a self-managed GitLab instance in your company. And for those scenarios, many companies actually create their own self-managed GitLab installation for the whole organization. And on that instance, all the company teams can host their Git repositories and configure the CI/CD pipelines for them. So it will work pretty much in the same way as you see here, and the UI will be same, but it will be completely managed by your administrators. And for those projects that you host on your GitLab installation, you can of course create self-managed runners, which you can attach to your GitLab installation. For the self-hosted GitLab instance, in addition to specific and group runners that we saw in the GitLab.com installation, you can also register your own self-managed shared runners. So again, you manage the whole setup, all the infrastructure yourself. There is one more thing I want to quickly mention regarding the GitLab runners and the GitLab instance that these runners are connected to, and regarding the versions of the runners. Now, GitLab server or GitLab installation is a different program that is installed on a separate machine that basically manages the whole GitLab setup. And GitLab runner is a different program that we install on other servers, and then we connect it or register it to the GitLab instance. So these are two separate programs with their own versions. So the question is, how do we make sure that the versions of these two, so the GitLab runners and the GitLab server, are in sync and compatible, especially when we manage the setup ourselves? So for example, it could be that GitLab.com platform actually updates the GitLab server version, but we have a self-managed specific or group runner that is running with an outdated version. So what are the compatibility rules here? According to the GitLab's own documentation for the runners, for compatibility reasons, the GitLab runner major minor version should actually stay in sync with the GitLab's major and minor version. And it could be that older runners may still work with the newer GitLab version, and vice versa. However, there could be some features that may not be available or may not work properly if these versions differ from each other. GitLab actually guarantees the backward compatibility between the minor version updates. But again, it could be that in a minor version update, a new feature gets added to GitLab that can only be executed and used on a GitLab runner with the same minor version. So on an older GitLab runner, you will not be able to use this feature. And again, for the scenario where you use gitlab.com and you have your own self-managed runners, GitLab suggests to keep the runner updated to the latest version because, again, gitlab.com also gets updated continuously. So you'll have to make sure your runners are also up to date so that everything works properly. And also the new features of GitLab can be used there. So that's something to keep in mind when you're managing your own runners or the complete GitLab installation. So to recap what we've learned in this chapter about GitLab architecture and setup, first of all, we have two different constellations of GitLab setup. One is the GitLab's own software as a service offering, which is gitlab.com, where me and you, all of the GitLab users, have accounts and can create repositories and configure pipelines. And the second one is a completely self-managed GitLab installation. And this is, as I mentioned, very common in companies because companies want to have control over their repositories and they want to host them on their own infrastructure in own data centers. On the second level, once we have that GitLab installation in place with projects and CI/CD pipelines, for those CI/CD pipelines, we would need to configure GitLab runners, which actually execute the jobs on those pipelines. And we saw that we have three types of runners that can be registered with the GitLab instance. We have the shared runners, which gitlab.com instance actually provides us out of the box as a managed shared runner. And in addition to those managed shared runners, we have a specific runner for one or more specific projects, or we have a group runner for a GitLab group, which can be shared by all the projects and repositories in that group. And for a self-managed GitLab installation, we have to, of course, manage the shared runners also ourselves. And on those runners, we then have executors, which are the ones actually executing the jobs. And we saw we have multiple types of executors, and a number of types of executors may change, but the most common and important ones we saw are the shell executor, which basically executes the jobs directly on the operating server of the runner, whether it's Windows, macOS, or Linux. We also have Docker and Docker machine executors, which executes the jobs inside Docker containers. We also have virtual machine executor, which executes the jobs in virtual machine environment. We have Kubernetes executor that will run the jobs in Kubernetes pods, and so on. And we also saw that as an administrator of GitLab installation, you'll have to create those runners, register them with the instance, and make them available for your developers. And then once those runners are available, developers of the applications who are configuring the CI/CD pipelines have all the flexibility to decide which job executes where, on which runner, with which executor, which Docker image will be used for a Docker executor environment, and so on. And we reference the runners for each job using the tags that get applied to them when we register a runner.